finishing up section 1.2 fractions. Now we are adding and subtracting fractions. So, when you add in subtractions, what you need to know is the denominator, the bottom number, has to be the same. 3/5 plus 1/5 is 4/5. So you just add the numerators. Denominator stays the same, which is great when the denominator is already the same. If the denominator is not already the same, then you have to make equivalent fractions. Now, the easiest way to go about this is to multiply each of these together to get your common denominator. So if I have 5 and 4, what I can do is 1 over 5, my original, and I'm going to multiply that by 4 over 4. I can do that mathematically speaking because 4 over 4 is just 1. So if I multiply this whole thing by 1, that's what I'm doing, is I'm not changing it at all mathematically. So then on the other one, 3/4, I'm going to multiply that one by 5 over 5. Which is, again, multiplying it by 1, so that keeps it equivalent. So this becomes 1 times 4 is 4, 4 times 5 is 20, 4 over 20, plus 5 times... Oh, that's why. Oh, sorry if that confused you. I rewrote this as 3/5 instead of 3/4. So I made the mistake from here to here. So anyway, 3 times 5 is 15. 5 times 4 is 20. So now I have these equivalent fractions that I can add. So 4 plus 15 equals 19. Denominator stays the same at 20. (19 over 20 can't be reduced, so I'm not going to do anything to that one. On part C, this one's going to be a multi-step one because I have a mixed number. So first I'm going to convert it. 2 times 3 is 6, plus 2 is 8. So 8 over 3 plus 8 times 1 is 8, plus 3 is 11, so 11 over 8. And now I'm going to multiply 8 over 3 by 8 over 8, because of this 8, and 11 over 8 by 3 over 3. So I take the denominator from the other one, and the denominator from the other one, and that's how I get my equivalent fractions. So this becomes 8 times 8 is 64, 3 times 8 is 24, 11 times 3 is 33, 8 times 3 is 24. So my answer here is 64 plus 33, which is 97 over 24. And I'm going to go ahead and leave that as my answer. I'm going to double back on that just a little bit. 97 over 24. There's a couple ways I can check this. 97 divided by 24 is not a whole number, so I'm not going to do that. If it's a whole number, I can write it as a whole number. The factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So I'm going to check all those. Divided by 3, 97 divided by 4, 97 divided by 6. And I already know 97 is not divisible by 2. So none of the factors of 97 is not divisible by any of the factors of 24. So I can't reduce that fraction at all. So to further practice, I'm not going to worry too much, wrong way, about the mixed fractions, so mixed numbers. So 1/2 multiplies by 5 over 5 from that bottom one. 3/5, and multiply that by 2 over 2. So I have 5 over 10 plus 3 times 2 is 6 over 5 times 2 is 10. So 5 plus 6 is 11 over 10. And that's my answer for part D. In subtracting, the only thing we do differently is instead of adding the denominators, we subtract the denominators. So I have 4/3 minus 3/4. So 4 over 3 times 4 over 4 from there, minus 3 over 4 from this one, times 3 over 3. So 4 times 4 is 16 over 12, minus 9 over 12. 16 minus 9 is 5 over 12. 5 is a prime number. 12 is not divisible by 5, so that's my answer. In part F, 3 over 4. Oops. Multiply that by 5 over 5 minus 1 over 5 times 4 over 4. 3 times 5 is 15 over 20 minus 4 over 20 equals 11 over 20. And that's my answer. The very last concept takes in a few of these different skills and puts them together. Is a given number a solution to that equation? So I have the equation x minus 2/9 times x equals 1. Can x equal 1 and 2/7? So the first thing I'm going to do is convert that to a mixed number. So 7 times 1 is 7, plus 2 is 9, so this is 9 over 7. So I plug that in for both of the x's. So 9 over 7 minus 2 over 9 times 9 over 7 equals 1. Drop down this 9 over 7 because I'm not going to use it yet. And then multiply these. 2 times 9 is 18. 9 times 7. Actually, I can reduce this already before I do that, because if I'm multiplying these, I have a 9 on the top and a 9 on the bottom, so those can divide out. So that can be 2 over 7. 9 minus 2 equals 7. Denominator stays the same. And 7 over 7, any number divided by itself, gives you 1. So yes, this is a solution. Finally, 3 over 20 for W, so 1/5 minus 3 over 20 equals 1/3 times 3 over 20. So I'm going to deal with each side separately. So I can multiply this out the same way that I did. So I could multiply the 1/5 by 20 over 20 minus 3 over 20 times 5 over 5. That'll give me the equivalent fractions. Wait a minute, what did I just do wrong? Oh, this is 3 over 20. That will always give me a common denominator. But what I can also notice is that 5 is a factor of 20. So what I can actually do is write this as as 4 over 20 by multiplying the top by 4 and the bottom by 4. And then 3 over 20 from the previous one. And then on the other side, 1 times 3 is 3. Actually, I don't need to do that either. Sorry. 3 over 3 here, those can divide out, so I have 1 over 20. 4 minus 3 gives me 1. 20 is equal to 1 over 20, so yes, This one is also a solution. Sorry if I got a little bit cryptic in there a couple times. Both ways will work for the equivalent fractions. If you can note that this number is a factor of this number, then you only have to convert one of them. But the method that we used on the previous page will always work for getting yourself a common denominator, just sometimes you have to reduce the fraction at the end. So that is it for section 1.1. Your homework is kind of a lengthy one. This may or may not be split over 2 days. I'm not entirely sure yet. 1, 3, 7, 9, 16, 21, 33, 35, 47, 52, 78, 80, and 100. So that's out of your book. Make sure that you have checked out that book. It's the Blitzer book from the library. Thank you very much. Have a lovely day.